use the given function to set up and simplify the following. F of 2, f of 2x, f of negative x, 3 times f of x plus 2, and then f of x plus a. The given functions are x squared minus 2x plus 1 and 1 over x. We can create a little table starting with our given function x squared minus 2x plus 1, and we're going to simplify the following according to the instructions. F of 2 means that anywhere we see an x, with these notations, means that anytime we see an x, we're going to replace it with whatever's inside these parentheses. This is our meta variable, our meta here, f of x. F of x is x squared minus 2x plus 1. It's a function evaluated at x. I want to see this function evaluated at 2. So anytime I see an x, I'm going to replace it with a 2. Similarly, anytime I see an x, I'm going to replace it with 2x, or then negative x. And then I'm going to multiply the whole thing by 3. I'm going to take the original, add 2 to it. And then finally, I'm going to replace x with an x plus a. And we're talking about these x's in our original function. So here, I'm going to replace these two x's with a 2, just a substitution. So this is 2 squared minus 2 times 2 plus 1. So everywhere I saw an x, I replaced it with 2. That's a substitution. I'm evaluating this function at 2. Well, I'm going to simplify this. 2 squared is 4, minus 2 times 2 is 4, so 4 minus 4 is 0. 0 plus 1 is 1. That's not very exciting, but we'll take it. It's a simple answer. All right, I'm going to shift this to the left a little bit to give us some more room. 2x is going to replace x now, so we have 2x squared minus 2 times 2x plus 1. Notice I've used parentheses here to make sure that I didn't break any algebraic rules, your PEMDAS rules. So I want the exponent to distribute across this multiplication, which is both the 2 and the x. So this is 4x squared, where the 2 applies to, this exponent applies to both the 2 and the x. And then we're going to distribute, we're going to multiply negative 2 times the 2 and the x. It stays negative. So 2 times 2x is 4x. And then plus 1, that's just plus 1. And we're done simplifying that one. Replacing x with negative x. This is often a test, something that we'll do for a test for symmetry to see if there's an odd or even symmetry. So this is a good one to practice. Replacing x with negative x. So we have negative x, again using parentheses, squared, minus 2 times negative x plus 1. Simplifying this, negative x times negative x, which is negative x squared, is just x squared. Negative 2 times negative x is positive 2x. And then plus 1. That constant term is just hanging around because it has nothing to do with x. 3 times f of x. Well, this is 3 times the whole original function. We can see that as 3 multiplying by everything that was in our original function. So this is 3 times x squared minus 2x plus 1. So I'm going to distribute that 3 across each one of those 3 terms, which will give us 3x squared minus 3 times 2 is 6, x, 3 times 1 is 3. F of x plus 2. We're going to take our original function, don't do anything to it, and then we're going to add 2 to the very end. So this is x squared minus 2x plus 1, the original f of x. Then we're going to add 2 to the end of it. Well, simplifying this is only going to add the 1 and the 2 together, our constant term. So x squared minus 2x plus 3. Finally, f of x plus a. I'm going to replace x with x plus a. This may take a little more room, may require a little more room, so we're going to do x plus a in parentheses, that's squared, minus 2 times, in parentheses, x plus a, plus 1. Simplifying this, we need to expand this. You can use FOIL, you can use double distribution, you can put them next to each other and use your rainbows, however, whatever process you'd like. You can do a vertical stack or you can use the box method, but we know that this is one of the special cases. We'll cut to the chase. This is x squared plus 2ax plus a squared. Then we're going to distribute the 2 to the x and the a, so it's a negative 2x minus 2a plus 1. We're going to combine like terms and simplify. How many x squareds do I have? Just one, so that's x squared. How about a squareds? Just one a squared, and it's a positive, plus a squared. How about the a and x combined? Just the one a and x, so plus 2ax. Let's go with our x's, then our a's. We don't have anything that can be combined, so really 2x minus 2a plus 1. There was no simplification, we just reordered it a little bit to double check. If it helps while you're reordering, while you're collecting like terms, you can cross them off as you go. As you write down the x squared, cross off all the x squareds. Look for the a squareds next, cross it off, and this way, as you go through and systematically cross them off, it can save you time and energy and frustration, frankly, of looking through everything over and over again as you sift through all of the garbage.